Hello La Rochelle, here we are again. Some geography with Miss Blakemore, your favourite. Actually technically it's Mrs Blakemore, whatever, we'll get there later. So, in front of me here is a fantastic example of a smaller style glacier, and it's a cirque glacier. We know that because of the sort of armchair shape that we can see. So if we look right at the top, and we've got some of these peaks occurring, we call those pyramidal peaks, I'll get there later. But down to the left of that, we can see what kind of looks like ice that's emerging from the snow. And in there, I would call that quite a stereotypical armchair shape. And that's why we know this is a cirque glacier. And the cirque glacier, this is where all glaciers originate from. So it's really exciting. And actually that glacier would have been much, much larger, but sadly, probably due to climate change, this is why it's retreated further a little bit up the mountain. And how this is formed was over many, many years on usually north-facing hollows, natural indentations within the mountainside. Over many, many years, snow has fallen, it's not melted seasonally, and therefore has layered up over time, and with lots of pressure has condensed and compressed into ice. So it's a very special type of ice that we get in a glacier. It's unlike what you get when you put some water in your ice cube tray and you shove it in the freezer. Because of that condensing and compressing of snow layer on layer, you're squeezing out all of the air in between those layers of snow, which forms crystallizations, which helps with the movement internally. It's called internal deformation, and it allows those crystals to slide over each other, and in doing so allows the glacier to move, which is why sometimes people will call it a river of ice. Now in a cirque glacier, it's all collected in this hollow, and over time so much snow compressed into ice to form this glacier will have collected that it'll simply not be able to be held in that hollow anymore, and will naturally, under gravity, start to slip out of that hollow in a rotational fashion. And it's that rotational slide. Hang on, we've got a full we've got a full crew come in. I'm just going to stop.
Yeah, in 2010
They don't want to join the party. They're not interested in the jockey lessons. Oh yeah, but he's excited. See? You hear that? He's excited about that glacier. Yeah. So this rotational slide is what creates this armchair shape, and it deepens and steepens that hollow. When eventually, very sadly, that glacier will retreat, maybe it won't, hopefully it won't, but we see it all over the world. Obviously you've had retreating glaciers just naturally after the last glacier, maximum 11,500 years ago. What will be left behind is a really deepened hollow, and if the right conditions have been created, the meltwater from that glacier will have collected in that hollow to form what's called a Corrie lake or a tarn. Right, back to the studio.